Let's take a look at replacing the battery on a modern vehicle and some of the extra steps that might be required. Today's vehicle is a 2013 Ford Escape with a 2-liter turbo engine, 118,000 miles on it. Now, this vehicle was brought into the shop with a simple customer request that they'd like the battery replaced due to the age. The customer just bought the vehicle for his daughter and didn't want to have any problems, so he simply wanted the battery replaced. Now, on older vehicles, we would just go ahead, disconnect the terminals, unbolt the battery, install a new one, reconnect the terminals, and maybe we'd have to do some radio resets or reset the clock or maybe a throttle reset. But in today's newer vehicles, it's much more involved. As we look at the location of the battery on this Escape, there's some plastic covering and a few things have to come out of the way. This is located near the left front strut tower in the vehicle, and you can see it's tucked in there quite well. In order to make sure that he's doing the job properly, the technician decided to look in service information to see if there are any tips or tricks that might be required. I want to call attention to the installation procedure and the note at the bottom of the page there. It says, if installing a new battery, use the scan tool to carry out the battery monitoring system reset after the battery is connected. Well, if we take a look at the special note and go to the battery monitoring sensor system description, there's a note that says, unless the battery is being replaced, do not reset the battery monitoring sensor using the scan tool. This reset is reserved for new battery installation, such as what we're doing here today. This reset clears the learned battery data, the battery time in service, and affects the aging parameters, which have been learned since the installation of the battery. So as we look at the vehicle again, you'll notice on the negative cable, we've got a battery sensor there. And again, looking in service information to find out a little bit more about these systems, we can read that the battery monitoring system is going to be typically attached to the negative battery terminal, which provides a ground for the sensor. The battery monitoring sensor is integrated with a negative battery terminal clamp and cable assembly and cannot be serviced separately. The battery monitoring sensor measures voltage, current, and temperature of the battery and uses these inputs to calculate the battery condition, transmitting this information through the LIN network circuit to the body control module. The battery monitoring sensor has a 2-pin connector providing battery voltage and LIN connections. The battery monitoring sensor is an input to the electrical energy management software. If the sensor malfunctions due to wiring issues or failure, a diagnostic trouble code will be set. In most cases, the electrical energy management functions are turned off until the sensor operation is restored. If the battery monitoring sensor is removed from the negative battery post, all internal parameters except battery time and service reset to a standard setting. These parameters are relearned during normal recalibration intervals. If the battery has been charged or jump-started by connecting directly to the battery post or the battery monitoring sensor, it's going to force an internal reset by removing the battery monitoring sensor from the battery negative post, then reconnection. Now, looking at the network here and how this actually intertwines with the rest of the vehicle, we can learn that the Smart Regenerative Charge System primary strategy is stored in the body control module. The BCM receives all the important information relating to the battery condition from the battery monitoring sensor via the LIN network. The BCM calculates and sends the set value needed for the generator charging voltage via the high-speed CAN network to the powertrain control module. The PCM then adjusts the value received, if necessary, and sends it to the generator via the LIN network. The charging voltage is adjusted depending on various parameters such as the current level of engine efficiency. The smallest possible set value for the generator voltage will be 12.2 volts, while the maximum charging voltage can be anywhere between 14.5 to 14.9 volts. However, under certain conditions, when the battery is in a refresh phase, the voltage may occasionally reach up to 15.2 volts. So now we see a little bit how this battery current sensor really plays into the greater picture here, all in the efficiencies of fuel economy and engine performance, as well as battery life longevity. So the battery's been installed by the technician. He's going to plug in his scan tool, and first thing he's going to do is go into the body control module. Next thing, he's got a couple different options here, and he's going to select functional tests. Once he's in that menu, the first item on the list there is battery monitor system reset. And so the scan tool prompts him to cycle the key, turn the ignition on. It's important at this time not to have the vehicle running, but simply have the ignition on. And it also says, this function resets the battery monitoring system. Perform this function following battery replacement, BCM replacement, or when otherwise instructed by the workshop manual. He's going to hit yes to continue. And after about 5 seconds, the tool says test is complete, turn ignition off. And just like that, he's followed that procedure. Now you might be wondering, what happens if I don't do this? Well, it's going to affect the life of the new battery that's installed in the vehicle. It could be overcharging, undercharging, or a whole mix of things by thinking it's still got that old battery in there. And so anytime a battery is replaced in a new vehicle, we need to look at service information or also look on the scan tool to see if the option is available. If it is available and required, we need to go ahead and reset the parameters here to ensure the longevity of the new battery.